Welcome to this deep dive
Okay.
into the world of problem solving
Nice.
through the book The Art of Problem Solving
Okay.
by Richard Rusczyk and Sandor Lehoczky.
Cool.
We've got excerpts from the book itself
Okay.
and alongside insights about math competitions and cool resources. It's all blended together.
Very cool.
So think of this as like a crash course
Okay.
in sharpening your math skills.
Nice.
Whether you're a student,
Yeah.
a teacher, or just someone who loves a good mental challenge.
Right. Oh,
So-
yeah.
What's really cool about this book is that
Yeah.
it's not like your typical textbook.
It's really not.
It's not about memorizing formulas.
Not at all.
It actually dives into like the heart of problem solving,
Absolutely.
showing you how to think critically
Yeah.
and approach challenges in new ways.
Exactly.
Yeah, and they're really big
Mhm.
on this idea of active learning,
Yeah.
meaning it's not enough to just read through it.
Right.
You have to actively engage
Get your hands dirty.
with the problems, work through them, and really get your hands dirty
I like that. Yeah.
with the concepts.
Totally.
One thing I thought was really interesting is that
Yeah.
they emphasize
Okay.
the importance of learning subjects simultaneously,
Okay.
not in isolation.
So not just like algebra and then geometry, but
Yeah, not just keeping them in those separate
yeah,
boxes.
they see how it's all interconnected.
Yeah, so they show you how it's all interconnected.
Exactly.
You can kind of develop a more holistic understanding
I like that a lot.
of math.
Yeah.
Okay, so the book encourages you to think about math differently.
Mm-hmm.
What kind of topics does it cover?
Well, it covers a wide range of topics, and
Yeah.
it really reflects like the interconnectedness that we're talking about.
Okay.
You'll find chapters on circles,
Okay.
triangles,
Mm-hmm.
polygons, inequalities,
Yeah.
statistics, probability,
Good.
and even some fun stuff
Ooh, fun stuff.
about number bases and divisibility tricks.
Thanks.
It's like a mathematical buffet.
I love it.
Yeah.
Speaking of fun stuff,
Okay.
the book also mentions
Yeah.
some pretty intriguing math competitions.
Oh, yeah. Like what?
So, for example, there's the USAIM MTS,
Oh?
the USA Mathematical Talent Search.
What's that all about?
And get this, it's funded
Okay.
by the National Security Agency.
Wow.
Apparently,
Interesting.
they're all about teaching students how to write proofs,
Okay.
which is a pretty valuable skill
Yeah.
beyond math.
Absolutely.
It forces you to think clearly,
Yeah.
express your ideas precisely,
Yeah.
and construct arguments that stand up to scrutiny.
For sure.
The book also mentions the Mathematics and Informatics Quarterly,
Uh.
or M&IQ.
M&IQ.
What's that all about?
Well, it's a journal that's
Yeah.
packed with articles from mathematicians all over the world.
Oh, wow.
And while it's accessible to high school students,
Okay.
it offers fresh insights,
Really?
even for experienced mathematicians.
Yeah, cool.
Yeah. It's a great example of a resource that pushes you to think beyond the textbook
Okay.
and explore different mathematical perspectives.
I like that a lot.
Yeah.
Now we can't forget about
All right.
the famous path
Oh,
that
yeah.
leads to the Math Olympiad Summer Program,
Okay.
the MOP.
The MOP.
It starts with the American Mathematics Competitions, or AMC,
Mm-hmm.
and it's for those who are really serious
Right.
about competitive math.
Yeah.
And here's a cool fact.
Okay. What's that?
Some of the problems
Yeah.
in the art of problem solving
Mm-hmm.
were actually used at the MOP.
Oh, wow.
Yeah,
That's pretty impressive.
it is. It
Yeah.
shows that the concepts and techniques
Right?
covered in this book are directly relevant
Hmm.
to high-level math competitions.
For sure.
It's like having a sneak peek into the minds
Totally.
of those who create these challenging problems.
I love it.
Okay, let's dive into
Okay.
some of the specific math concepts
Right.
covered in this book.
Let's do it.
Starting with exponents and radicals,
Okay.
these can be a little tricky,
Yeah.
especially when you're dealing with things like square roots.
For sure.
A common mistake
Right.
that people make is
Yeah.
confusing x squared equals 9
Mm-hmm.
with x equals the square root of 9.
Okay. So, it's
Yeah.
really important to remember that
Yes.
x squared equals 9 has two solutions.
Right, because you could
Positive 3 and negative 3.
square either one and
Yeah.
get
Exactly.
9,
Yeah.
but x equals the square root of 9.
Yeah, it only has one.
Only has one solution
Oh, the 3.
because the square root symbol
Yeah.
is defined as
Yeah.
the principal or positive square root.
That's a good point. So,
Yeah, it's those little details
yeah, it's those little details
that can trip you up.
that can really trip you up if you're not careful.
Yeah, if you're not careful.
Now, what about logarithms?
Oh, okay.
Those can be a bit intimidating
Yeah, they can be.
for some people. They're kind of like the inverse of exponentiation. So
Right.
they allow you to convert
Mhm.
between exponential and logarithmic forms of equations.
Right.
Solving logarithmic equations can be tricky, though,
I bet.
especially when they involve square roots
Okay.
or other like nonlinear terms.
So how do you approach those kinds of problems?
Well, the book offers this really clever strategy.
Okay.
Solve them as though they were linear equations.
Okay.
So, for
Yeah.
example,
Yeah.
if you have an equation with like the square root of x and the square root of y,
Okay.
you can substitute new variables for those terms and solve it as if it were a linear equation.
Got it.
Then you just substitute back to find the values of x and y.
Wow. So it's like...
It's a way of simplifying the problem.
Yeah, just simplifying it.
And making it more manageable.
That's cool.
Yeah.
It's all about finding those clever techniques that make those complex problems more approachable. Yeah. Now let's talk about word problems.
Oh, yeah.
Those can be a real headache.
They can be.
For some students.
I think for a lot of students, to be honest.
Yeah, probably. For most.
Right.
Word problems are all about translating real-world situations into mathematical language.
Exactly.
The book offers a clear 3-step process.
Okay.
Define your variables.
Okay.
Write your equations. Solve them.
Nice. So it's like having a roadmap.
It's like having a roadmap.
Yeah.
For navigating
those tricky
word problem scenarios.
I like it.
They use engaging examples too.
Oh, yeah, definitely.
Right.
Like they have problems about ages.
Yeah.
Ticket prices.
Yeah.
And even those classic rate problems.
Oh, yeah.
Like the one where...
I remember those.
Yeah, where someone drives at different speeds to and from their destination. They even have one about a guy named Jim driving at different speeds to his mother's house.
So they emphasize
the
importance of understanding whether quantities are directly or inversely proportional.
So directly proportional means that as one quantity increases, the other increases at the same rate.
Right.
While inversely proportional means that as one quantity increases, the other decreases.
Okay.
So it's like...
So like...
If you're driving at a constant speed, the distance you travel is directly proportional to the time you spend driving.
Right.
But if you want to travel a certain distance in a shorter amount of time, you need to increase your speed.
Right.
So speed and time are inversely proportional.
Got it.
In that case.
So it's about understanding those relationships.
Exactly.
And how they translate into mathematical equations.
And once you have those equations, you can use your algebra skills to solve.
To solve for the unknowns.
Exactly.
Okay, now let's get a little more abstract. The book also covers number bases.
Yeah.
Which is something
that most people don't encounter in everyday life.
That most people don't really encounter in everyday life.
Right.
Number bases are.
Different ways of representing numbers.
Okay.
So the familiar decimal system we use is base 10, which means that each digit represents a power of 10.
Yeah.
But there are other bases, like base 5, base 7, and so on.
Okay, so here's where it gets a little mind-bending.
Okay.
The last digit of a number in base 5 actually determines its equivalence class.
Oh, wow.
What does that even mean?
So it means that numbers in base 5 fall into groups based on their last digit.
Okay.
For example, all numbers ending in 0 in base 5 are equivalent to each other.
Gotcha.
All numbers ending in 1 are equivalent.
Okay.
And so on.
So it's like a way of classifying numbers based on their remainders when divided by 5.
Exactly.
That's pretty cool.
Yeah.
The book also introduces modular arithmetic.
Okay.
Which is a way of...
doing math with remainders.
Doing math with remainders.
So modular arithmetic can be used to find the last digit of sums and products. And it has applications.
Oh, cool.
In cryptography and computer science. But here's a key point.
Okay.
Division doesn't always work the same way in modular arithmetic as it does in regular arithmetic.
So that's something to keep in mind.
It is definitely something to keep in mind.
When you're exploring this concept, they also cover divisibility shortcuts, which are pretty handy.
Oh, for sure.
Like you can tell if a number is divisible by 2, 3, 5, 9, or 11 just by looking at its digits.
Yeah, those shortcuts are based on the underlying logic of using mods.
Okay.
So it's not just about memorizing rules, it's about understanding the principles behind them.
Totally, yeah.
All right, now let's move on to quadratics.
Okay. Those are equations that involve x squared. And they can be pretty challenging to solve.
They can be.
So quadratics essentially arise from the product of linear factors.
Okay.
So the book covers various factoring techniques, like finding two numbers that multiply to give you the constant term and add up to give you the coefficient of the X term.
Exactly.
And it shows you how to choose the right factoring method based on the signs of the coefficient.
Exactly.
And when factoring doesn't work, there's always the quadratic formula.
Right. The quadratic formula.
It's a little long.
Long and complicated. Right. But it always works.
But it always gives you the solution to a quadratic equation.
Exactly. Yeah. The quadratic formula is a powerful tool.
It is.
And what's really cool is that the book connects this idea of quadratics to the broader idea of polynomials. So it's like a gentle introduction to those expressions with higher powers of x.
Right, like x cubed or x to the fourth.
Exactly. Okay. And it introduces the idea that they too have solutions which are called roots.
Right.
Just like quadratic equations do.
So it's like
building upon what you've already learned.
What you've already learned about quadratics. And extending those concepts to more complex expression.
Exactly.
Now let's talk about manipulating algebraic expressions.
Okay.
Those could be a real jungle sometimes.
They can be.
So manipulating algebraic expressions involves simplifying them, combining like terms, factoring them, and sometimes even expanding them.
Right.
And the book emphasizes that the key is often to determine the product of the variables.
Okay.
For example, if you have an expression involving x plus y and x squared plus y squared, you might need to find the product xi.
Exactly.
To simplify the expression.
To simplify it.
And they walk through
they do.
some pretty challenging examples.
Oh, yeah, like finding x to the fourth plus y to the fourth, given x plus y and x squared plus y squared.
Yeah.
That's a really good workout for those algebraic muscles.
Totally.
Yeah, and it shows you like how with a little bit of creativity and strategic manipulation, you can simplify these.
Yeah, it's like solving a puzzle.
It is like solving a puzzle.
Finding the right pieces to fit together.
Yeah, finding the right pieces and then putting them all together.
All right.
Yeah.
Let's explore the world of numbers a bit.
Okay.
So the book takes you on this journey through different types of numbers.
Right.
Starting with the integers.
Okay.
Which are whole numbers.
Right.
Both positive and negative.
Exactly.
Then it moves on to rational numbers, which can be expressed as fractions, and irrational numbers.
Okay.
Which can't be expressed as fractions, like pi.
Right, like pi.
And the square root of 2.
Yeah.
And then
there are those
mind-bending
complex numbers.
Complex numbers, which involve the imaginary unit.
Yeah. Right, where I squared equals -1.
Which is just crazy.
It's pretty wild.
It's so weird.
Yeah, complex numbers are fascinating.
Yeah, they are.
Yeah, they extend the number system beyond real numbers.
Okay.
And have applications.
In all sorts of things.
Yeah, in various fields.
Like electrical engineering.
Yeah, like electrical engineering.
Quantum mechanics.
Quantum mechanics.
The book also covers the concept of terminating and repeating decimals.
Right.
And how to convert them into fractions.
So it's all about building fluency.
Yeah.
With different number representations.
And they include this quote that really makes you think about the nature of mathematical discovery.
What is it?
It goes, God created the integers. The rest is the work of humanity.
Oh, wow.
I know it's a good one.
That's a good one.
It's a thought-provoking statement about the role of human ingenuity in expanding our understanding of the universe.
Yeah, we start with these fundamental building blocks, the integers.
Yeah.
And from there, we build upon that.
Explore new mathematical concepts and systems.
All right, let's shift gears.
Okay.
Talk about geometric transformations.
Right.
What are those all about?
So geometric transformations involve manipulating geometric figures in different ways.
All right.
So they include translations, which involve sliding a figure.
Gotcha.
Rotations, which involve turning a figure around a point. Deflections, which involve flipping a figure across a line. And dilations.
Got it.
Which involve enlarging or shrinking a figure. So the book explains how to describe these transformations mathematically.
It does.
Right.
Yeah, it shows you how to use equations and matrices
to
represent those transformations. And it even compares different coordinate systems for describing those transformations. Yeah. So, for example, polar coordinates, which use distance and angles to locate points, are better suited for describing rotations.
Gotcha.
While Cartesian coordinates, which use X and Y coordinates, are simpler for describing translations.
So it's about choosing the right tool?
It's all about choosing the right tool for the job.
For the job.
Yeah.
That's interesting.
Yeah.
It's like choosing the right language.
Exactly.
To describe a particular concept.
Totally.
Now, what about proofs?
Okay.
Those can be pretty intimidating.
Yeah.
For some students.
Yeah.
Proofs are
the heart of mathematics. Oh, wow, the heart of mathematics.
Yeah.
So they allow us to establish the truth of mathematical statements. Beyond a doubt.
Beyond any doubt.
So the book highlights the specific language that's used in proofs, like explaining...
What are some of those terms?
Terms like distinct, which means different without loss of generality.
Yeah.
Which means we can assume a specific case without affecting the overall argument.
Without affecting the overall argument.
Necessary and sufficient.
Okay.
Which refers to the conditions for a statement to be true.
Right.
And those quantifiers.
Okay.
Like for all.
Right.
And there exists, which specify the scope of a statement.
Yeah, so it's like learning the grammar.
It's like learning the grammar.
Of mathematical argumentation.
Of mathematical argumentation.
Yeah.
And they cover different proof techniques.
Yeah. What kind of proof techniques?
Yeah.
Direct proof.
Okay. Direct proof.
Where you start with known facts.
Okay.
And logically deduce the conclusion.
All right.
Proof by contradiction.
Okay.
Where you assume the opposite of what you're trying to prove and show that it leads to a contradiction.
To a contradiction, right.
And then proof by induction,
which
is used to prove statements that are true for all natural numbers.
Okay.
And they even include some fun examples.
Okay.
Like a proof
what is it?
That all people are the same height.
Oh, yeah, I've heard that one before.
Which is a classic example of faulty induction.
Yeah.
It highlights the dangers of making generalizations.
Right.
Based on a limited number of cases.
Exactly. So it's a reminder.
Yeah, to be careful about our assumptions.
Absolutely.
And to scrutinize our reasoning.
Scrutinize our reasoning, yes.
They also introduce the pigeonhole principle.
The pigeonhole principle. What's that?
Which is a surprisingly powerful tool for solving certain types of problems.
Interesting.
The pigeonhole principle states that if you have more pigeons
more
in pigeonhole,
at least
one pigeonhole must contain more than one pigeon.
Okay. That seems pretty obvious.
It does sound pretty obvious.
Yeah. But you can apply it?
But it can be applied to all sorts of problems.
Like what kinds of problems?
From number theory to combinatorics.
Oh, wow.
Yeah.
That's really cool.
And then they also present a convincing but flawed proof that -1 equals 1.
Well, that's a good one.
It's a cautionary tale.
Yeah.
That reminds us
to be vigilant.
To be very vigilant and double check our reasoning.
I like it.
Even when it seems airtight.
Yeah. Even when it seems airtight.
It's all about developing that critical thinking muscle.
Right.
And being able to spot those subtle errors in reasoning.
For sure.
Now let's talk about those resources.
Okay.
For aspiring mathletes.
Yeah.
So the book provides a wealth of information.
Cool.
About math competitions.
Like what?
Like the AMC.
Okay, the AMC.
The the USO.
Okay.
And the Math Olympiad Summer Program.
Right, the MOP.
It offers tips.
Nice.
For preparing for those competitions.
Like what?
Including practicing with past problems.
Okay.
Developing time management skills and learning how to approach those challenging Olympiad level problems.
Nice.
And they also talk about the importance of community.
Okay.
Right.
Yeah, they emphasize the benefits of working with others, sharing ideas, learning from each other's strengths, highlighting the power of collaboration in mathematical problem solving.
So it's really cool.
Yeah.
And they even provide links.
Oh, nice.
To online resources.
Like what?
Like their own art of problem solving website.
Their website is fantastic.
Yeah.
Yeah, it's got forums.
Oh, cool.
Where students can discuss problems, ask questions, get help from others. Yeah. It offers online classes and a variety of other resources for those who are passionate about math.
It sounds like a really...
It's a fantastic resource.
Fantastic resource.
Yeah.
So after all this, what's the takeaway?
Yeah, what's the takeaway?
For listeners.
Why should they care about the art of problem solving?
Why should they care?
Well, it's not just about math.
Okay.
The skills you develop through problem solving, the ability to think critically, analyze information, approach challenges strategically.
Okay.
Those are valuable in any field.
Exactly. So whether you're a student, teacher scientist, engineer, entrepreneur, or just someone who loves a good challenge.
Right.
This book offers valuable insights and tools.
It's not just about finding the right answer.
Okay.
It's about cultivating a mindset, way of approaching the world. Yeah.
With curiosity, creativity, and a willingness to embrace challenges.
I like that.
Yeah.
Embrace challenges.
It's about developing those mental muscles that allow you to tackle any challenge with confidence and ingenuity.
Yeah.
And speaking of challenges, the book also delves into specific problem-solving strategies.
Okay.
For example, it breaks down those often intimidating word problems into a manageable 3-step process.
Okay, remind me.
Yeah.
What are those 3 steps again?
First, you define your variables. What are the unknowns you need to solve for? Assign them letters or symbols.
Okay.
Then you translate the words of the problem into mathematical equations using those variables.
Got it.
Finally, you solve those equations using your algebra skills.
So it's like taking something that seems messy and turning it into...
into a neat and organized equation.
A neat and organized equation.
Exactly.
I like it.
And they provide...
a variety of engaging examples to illustrate this process.
Like what?
Including problems involving ages, ticket prices, and those classic rate problems, like the one about Jim driving at different speeds.
I remember those rate problems. They always involved distances, speeds, and times.
Right.
And figuring out how they all related to each other.
Exactly. And the book emphasizes the importance of understanding whether those quantities are directly or inversely proportional.
Right. Directly proportional means that as one quantity increases, the other increases at the same rate. And inversely proportional means that as one quantity increases, the other decreases.
Right.
Like if you're driving at a constant speed, the distance you travel is directly proportional to the time you spend driving. But if you want to travel a certain distance in a shorter amount of time, you need to increase your speed.
Right.
So speed and time are inversely proportional in that case.
Exactly.
Yeah.
And understanding those relationships is key to setting up the right equations.
Right.
To solve the problem. The book also covers percentages, showing you how to convert between decimals, fractions, and percentages, and how to solve problems involving percentage increases and decreases.
Okay.
It's all about building fluency and understanding how these different representations relate to each other.
Okay, so we've talked about exponents, radicals, logarithms, word problems, and percentages.
Right.
What other cool math concepts does the book cover?
Well, it goes back to those number bases we talked about earlier.
Okay.
Remember how we said that the last digit of a number in base 5 determines its equivalence class?
Yeah, that was pretty mind-blowing.
Well, the book delves deeper into that concept, exploring the patterns and relationships within different number systems.
Okay.
It introduces modular arithmetic, which uses mods to find the last digit of sums and products.
Odds.
Yeah, it's short for modulo, and it basically refers to the remainder when you divide one number by another.
Okay.
For example, 7 modulo 5 is 2.
Yeah.
Because when you divide 7 by 5, you get a remainder of 2.
Okay. I'm starting to remember this from my math classes.
Yeah, so modular arithmetic is all about working with those remainders.
Okay.
It's a powerful tool, especially in number theory and cryptography.
Okay.
But here's the catch: division doesn't always work the same way in modular arithmetic as it does in regular arithmetic.
Oh, so that's something to keep in mind.
It is definitely something to keep in mind when you're exploring this concept.
When you're exploring this concept, they also cover divisibility shortcuts for numbers like 2, 3, 5, 9, and 11.
Yeah, those shortcuts are based on the underlying logic of using mods.
Okay.
And they can save you a lot of time when you're trying to figure out if one number is divisible by another.
Those divisibility rules were always fun.
They're fun.
Like a number is divisible by 3 if the sum of its digits is divisible by 3.
Exactly. It's all about understanding those underlying principles.
Okay, what about quadratics? Those were always a bit of a challenge.
Quadratics are polynomial equations where the highest power of the variable is 2.
Okay.
They often arise from the product of linear factors. The book covers various techniques for factoring quadratics.
Okay.
And it explains how to choose the right method based on those pesky coefficient signs.
Right, and when factoring doesn't work, you can always use the quadratic formula.
You can?
It's a bit long and complicated, but it always gives you the solutions.
It does. It always works.
Kind of quadratic equation.
Right. The quadratic formula is a powerful tool.
It is.
And what's interesting is that the book connects the concept of quadratics to the broader idea of polynomials.
Okay.
It's like a gentle introduction to those expressions with higher powers of x,
right,
and the idea that they too have solutions, which are called roots, just like quadratic equations do.
So it's like building upon what you've already learned about quadratic equations and extending those concepts to more complex expressions.
Yeah.
Now, remember how we talked about manipulating algebraic expressions earlier? Well, the book dives deeper into that topic as well, emphasizing the importance of determining the product of the variables when working with expressions involving squares, cubes, and higher powers.
Right.
Right, like finding x to the fourth plus y to the fourth, given x plus y and x squared plus y squared.
Exactly.
It's a great example of how those seemingly complex expressions can be simplified with strategic manipulation.
Yeah.
It's like solving a puzzle, finding the right pieces to fit together.
Exactly. And speaking of puzzles, the book also takes you on a journey through the fascinating world of numbers, from those familiar integers to those mind-bending complex numbers. It covers terminating and repeating decimals, showing you how to convert them into fractions.
And it even introduces the mind-blowing concept that not every polynomial equation has a real root. Right. Which is where those complex numbers come in, expanding our mathematical horizons.
Exactly. It's a reminder that there's always more to learn, more to discover in the world of mathematics. And speaking of discovery, the book includes another thought-provoking quote: "God created the integers. The rest is the work of humanity."
I love that quote.
That's a good one.
It really highlights the power of human ingenuity and our capacity to build upon those fundamental concepts to create new and amazing mathematical ideas.
Absolutely. And now, are you ready for some geometric transformations?
Bring it on.
The book delves into the world of translations, rotations, reflections, and dilations, explaining how to describe these transformations mathematically.
Right, like using equations and matrices to represent those transformations. And I remember how it compared different coordinate systems for describing those transformations. Polar coordinates are better suited for rotations, while Cartesian coordinates are simpler for translations.
Exactly. It's all about choosing the right tool for the job.
Choosing the right tool for the job.
And the book also explores what transformations preserve, such as collinearity.
Okay.
Where points remain on the same line, area, shape, and angles. It's like understanding the rules of the geometric game, how you can manipulate figures without changing certain properties.
What about proofs? Did we cover those already?
We touched upon them earlier, but the book goes into much greater depth. Okay.
It highlights the specific language used in proofs. Those terms like distinct, without loss of generality, necessary and sufficient, and those quantifiers like for all and there exists.
It's like learning the grammar of mathematical argumentation, the precise language you need to construct a valid proof.
Exactly. And the book covers various proof techniques like direct proof, proof by contradiction, and proof by induction, providing examples and explaining how to choose the right technique for different situations.
Okay.
It even includes those fun examples like the proof that all people are the same height, which illustrates the dangers of faulty induction and the need to carefully scrutinize your reasoning.
Right. And there's that convincing but flawed proof that -1 = 1, which serves as a cautionary tale, reminding us to be vigilant and double-check our work, even when it seems obvious.
Right. Those flawed proofs are great reminders that even the most seemingly logical arguments can contain subtle errors. It's all about developing that critical thinking muscle. And I love how the book introduces the pigeonhole principle, which seems so simple, but is surprisingly powerful if you have more pigeons than pigeonholes. At least one pigeonhole must have more than one pigeon.
Exactly.
It's a fun and memorable way to illustrate a principle that can be applied to a wide range of problems.
Absolutely. And speaking of fun, the book also explores some pretty cool resources for aspiring mathletes, like the USMTS, the MNIQ, and various math competitions leading up to the Math Olympiad summer program.
Those resources are amazing. It's inspiring to see how accessible those opportunities are for students who are passionate about math. And I love how the book emphasizes the importance of collaboration and community in math.
Right. They talk about the benefits of working with others, sharing ideas, and learning from each other's strengths. It's about fostering a love of mathematics and creating a supportive environment for exploration and growth.
And they even provide links to online resources like their own Art of Problem Solving website, which has forums, classes, and a ton of other resources for math enthusiasts.
That website is a fantastic hub for anyone who wants to delve deeper into the world of math. It's a great example of how technology can be used to connect people and create a community around shared interests.
So after exploring all these concepts, strategies, and resources, what's the key takeaway for listeners? Why should they care about the art of problem solving?
Well, it's about more than just math, the skills you develop through problem solving. The ability to think critically, analyze information, and approach challenges strategically, those are valuable in any field, whether you're a student, a teacher, a scientist, an engineer, an entrepreneur, or just someone who loves a good challenge. This book offers valuable insights and tools that can enhance your thinking and empower you to tackle real-world problems with confidence and ingenuity.
It's not just about finding the right answer. It's about cultivating a mindset, a way of approaching the world with curiosity, creativity, and a willingness to embrace challenges. And with that in mind, let's move on to some of the most surprising or memorable insights from our deep dive. Okay, so let's do like a quick recap of some of the highlights. From our deep dive into the art of problem solving, what are some of the most surprising or memorable insights that stood out to you?
Well, one thing that really resonated with me was the emphasis on active learning. Like you said, it's not enough to just passively read through the material. You have to engage with the concepts, wrestle with the problems, and make those connections for yourself. It's about cultivating a curious and questioning mind, always seeking to understand the why behind the what.
I totally agree. And the idea of learning subjects simultaneously. Not in isolation, right? Connecting different areas of math like algebra and geometry. That was really eye-opening for me.
It was for me too.
It's like seeing the bigger picture, the interconnectedness of it all. That makes math feel less like a bunch of isolated formulas. And more like a unified and elegant system.
Absolutely. And speaking of elegant systems, those resources for aspiring mathletes like the USMNTS and MNIQ are fantastic. It's inspiring to see how accessible these opportunities are for students who are passionate about math.
Those resources provide a pathway for students to challenge themselves, explore advanced concepts, and connect with others who share their love of math.
It's like a whole community of problem solvers supporting each other and pushing the boundaries of mathematical understanding.
Absolutely. And let's not forget about those practical problem-solving strategies. Like the 3-step approach for word problems: define your variables, write your equations, and solve.
It takes the mystery out of those often intimidating word problems and empowers you to approach them with a clear plan.
That 3-step process is like a roadmap. For navigating those tricky word problem scenarios.
Exactly. It breaks down the problem into manageable steps and makes it feel less overwhelming. And I love how they use engaging real-world examples to illustrate these strategies.
The examples make the concepts come alive and show you how they can be applied to everyday situations. And speaking of making things come alive, remember those clever techniques for solving those tricky equations. Like treating nonlinear equations as if they were linear. By substituting variables.
It's so clever.
It's mind-bending, but it works.
It does. It's a testament to the power of creative thinking and strategic manipulation in mathematics.
Sometimes you have to think outside the box and find those unconventional approaches to solve a problem.
Exactly. And speaking of thinking outside the box, the pigeonhole principle was a real surprise.
It was.
It seems so simple, yet it can be applied to such a wide range of problems.
It's like a secret weapon for problem solvers.
It is.
If you have more pigeons than pigeonholes, at least one pigeonhole must have more than one pigeon.
I love that.
It's a fun and memorable way to illustrate a powerful mathematical principle.
And let's not forget those flawed proof. Those serve as valuable cautionary tales, reminding us to be vigilant, scrutinize our reasoning, and never take anything for granted, even when it seems obvious.
Those flawed proofs are great reminders that even the most seemingly logical arguments can contain subtle errors. It's all about cultivating that critical thinking muscle and being able to spot those inconsistencies and gaps in reasoning.
And remember that inspiring quote, "God created the integers, the rest is the work of humanity."
I love that quote. It speaks to the power of human ingenuity and our capacity to build upon those fundamental concepts to create new and amazing mathematical ideas. It reminds us that math is not a static set of rules, but a dynamic and evolving field that's constantly being shaped by human creativity and exploration. And this deep dive has really reinforced the idea that mathematics is much more than just memorizing formulas or crunching numbers. It's a way of thinking, a way of approaching the world with curiosity, logic, and a willingness to embrace challenges.
It's about developing a problem-solving mindset that can be applied to any area of life. It's about seeing patterns, making connections, and finding elegant solutions to complex problems. And ultimately, it's about the joy of discovery, those aha moments when things click into place and you gain a deeper understanding of the world around you.
So if you're ready to embark on your own mathematical adventure, I highly recommend checking out The Art of Problem Solving or exploring some of those other fantastic resources we discussed.
Yeah.
Remember, the journey of learning is never ending, and the rewards of expanding your mathematical horizons are well worth the effort.
And as you delve into those problems, those concepts, those proofs, ask yourself this: how might thinking about math problems and proofs change the way you approach problem solving in everyday life?
Yeah.
How might it enhance your critical thinking, your creativity, your ability to see connections and patterns in the world around you?
That's a great question to ponder and remember. The journey of mathematical discovery is a lifelong adventure, so keep exploring, keep questioning, keep those minds engaged. Until next time, happy problem solving.